Hello everyone, welcome to my third video on reinforcement learning models. Now this is my third video and I've done Q-learning, DQN, and now we are doing policy gradient methods. However, I've also done videos on supervised learning models where I provided a code along tutorial on all these models from linear regression all the way to polynomial regression. I've also done deep learning models and I've explained and give code along did code along projects on these models from GANs, CNNs, RNNs, and LSTMs, long short-term memory. But in this video, we are going to do reinforcement learning and we are focusing on policy gradient methods. So let's jump to our Jupyter notebook and let's get started. All right, we have our Jupyter notebook up and let's get started. So the goal here is to balance a pole on a moving cart. For those who know the open cart environment, we're going to use CartPole-V1 and we're going to use PyTorch and the OpenAI Gym to do that. So what we are going to do is to rename this to policy gradient methods. And it's reinforcement learning. Perfect. So what we need to do here is to first things first, import necessary libraries. So even before I do that, let me just do, the goal is to balance using policy gradient methods. What does success look like? Successful when all right. Success when rewards hit 500. Perfect. So this will be marked down and I'm going to run this. All right, so let's get started. I'll be a little bit faster because I intend all these videos to be less than 30 minutes. But however, if you want a detailed explanation, we can then, I'll give you this code file. It will be in my I'll provide a link on the description so that you can get the access to the code file. All right, so to import necessary libraries, what we need here is to want to import Gym. We want to also import Touch and Touch. I want also to import Touch. And of course, my NumPy SNP. And lastly, for visualization, I want to import Matplotlib. Perfect. All right. So the Gym environment, that's where we get our reinforcement learning environment. That's where we get our CartPole. So Torch, NM, neural network, and also Optim. These are just neural networks and optimization tools. Then we want to deal with numerical computation, so we're going to use NumPy and also Matplotlib. I am going to use Matplotlib for visualization so that we can see what our code is doing. Perfect. All right, so let's go ahead now to set our hyperparameters. Right, for hyperparameters, we want to set our learning rate. I will set it on 0.01, which is basically how fast the policy network learns. Then we want to set gamma. I'll set it on 0.99. So gamma is the discount factor. basically how much future rewards matter. Then let's go ahead and set the episode count. Now, I usually go with 1000, but you can set 300, 500, depending on your need. So the total number of episodes, like when we're trying to balance this poll, the CartPole environment, we need to give it the total number it's going to try. Remember, it's a trial and error, so we want to set the number of times it's going to try to balance this. So that's why I'm setting it to 1000. So episode count to 1000. Then I'm going to do render is equals to false. I'll set it initially on false. This is basically where to visually display the environment. All right, let's go ahead and do our policy network. Perfect. So success, then run this one. And all right, let's do our policy network. All right, so what I'm going to do here is I'm going to do a function. Actually, all right, class, let me do it this way. Policy network. We're gonna set our neural network, then dot module, and then I'll close this one. Then on initial, okay, let me go ahead and action. All right, super. Our neural network. Then softmax. Here will be self.fc2. Then action. Actually, okay, all right. Actually, I don't need to do this at this time. I'll do self fc2, then linear. So what I'm doing here is defining the neural network, and we're inputting 4 features from the CartPole. Then the okay, let me see. Oh yes, perfect. So what I need to do now is set another forward cell x. Then I'll do, so the x here will be touch dot one. Then x again is equals to touch softmax x. Then my dimension here opposite on -1. Then I want to return x. Perfect. So we need to establish our reinforcement algorithm here. So to do that, what I need to do is to do class reinforce. Class, okay, reinforce. Then action dimension, and also policy. Network, our state dimension, and also action. Let's go ahead, self optimizer goes to optim, self dot policy, is equals to the learning rate that we set on 0.01. Self dot episode, we set it initially at 0, empty. I'm gonna set this one also at 0. So I'll go ahead and set another function which will tell how to which action to select. I'll explain in detail when I'm done typing. I'm just going with the flow right now. Touch the tensor. Set it on 0. Probes, self.policy, state, distributions, categorical. Sample, then episode log I want to return action. Also, let's go ahead and create another function Update policy. Up. Another class rather. All right, to do that, I'm gonna go discounted rewards, set it on empty list. This will set it on 0. Then for loop here for reward in request. Yeah, self episode. Cumulative reward is equals to reward plus our gamma. We're gonna multiply it by cumulative reward. Perfect. And discounted rewards. Perfecto. Then what I need to do, counted rewards is equals to touch. All right, discounted rewards is equals to minus divided by loss, set it on 0. Let me push it right up at the screen here. Then loss now multiplied by reward. Then right here dot step, and also I will need self.episode as an empty list, and self is another empty list. All right, so the meat and bones we are done. What I need to do is to visualize so that we can see if we're able to balance this. So let's create a visualization function, which I will just do visual. Oh my goodness. So what we need to do is to def plot rewards, then rewards. I want to set the figure size. This equals to, set it the way you want, but I prefer 10 by 5. Dot put $1 rewards label. Actually, label. What do you want to label it? P-sort reward. Then our x-axis, we just want to have an episode. The label for the y-axis, total, actually total reward, and this is a string. This is a string. Perfect. For the y label, what would be the title? You title this the way you want, but let's go training progress, actually off rain reinforce on CartPole. Title it the way you want. Also, let's see the legend. And let's show it. All right, let's encapsulate everything into one. So let's create the main training loop. And to do that, let's do environment. We say this code cut for version 1. Our agent is equals to reinforce. Space. Set it on 0. And yeah, and let's do episode. Set it again as 0. And episode and range P. Now reset it. Then we do total reward 0. Now I'll just put a while true, if render let me push it up a little bit. Okay, action, just to agent dot select. Next state, reward info is equals to action. Actually truncated here. Our total reward. So if done, I want it to break. Then let's do our agent update and episode. Only to append total reward. And also I want to print out let's do episode so that we can keep the track of the episodes. Then total reward. Out of this for loop, what I need to do is to plot rewards. So episode rewards. Then I need to close everything here. All right. So of course I've done some errors, but let's check. So what I've done here is to import necessary libraries. What we have is Gym, PyTorch, and NumPy, and Matplotlib for visualization. Set up my hyperparameters, and also went on to define my policy network. So I defined it as a neural network, and also reinforce my agent class. So I created a policy network and an optimizer, and also I stored the rewards and log probabilities for each step in the episode. Our actions converts the state to a tensor, passes it through the policy to get action, and also samples an action from the resulting distribution, then logs the log probability of the action for later use in learning. And I also set it up to update the policy. I just set up the update policy rule, and also what we need to do is to plot everything out, and also initialize the CartPole environment and agent. So what I'm going to do is to run this and see the errors and clean up the errors, and we can come up again back and see what we got. Alrighty, so I'm going to run it and double check all the errors. There you go. Alright, so I'm going to cleaned all the errors, so I'm gonna run it one more time. So on the first episode, our total reward was 15. Episode 10, we have still got 15. Let's jump to episode 50. We were down to 9. Remember, our success criteria is to hit 500. So episode 131, we have 123. When we jump to episode 199, we are starting to balance that CartPole, and so we balanced here on episode 199 and episode 200. We went down again one more time. Then at episode 262, we started to balance the pole. Then we dropped it here, but you can see we are starting to balance up the pole. There you go. Then you dropped one more time. Remember, we've got 1,000 episodes, so let me give it time for it to run. So basically what happens is, yeah, we're kind of no longer balancing here. But the CartPole environment is basically like this, where we have a moving cart here and a pole, and it either moves right or left depending on how this, if it's tilting to the left, this will move to the left. If it's tilting to the right, it will move to the right. The goal is to balance, or the goal is to hit 500, which means balance in our case here. So upwards of 500, we are balancing now. The model, the agent is learned to balance, and we see dropped a little bit here, but this should work. All right, that's basically what you're doing here, and that's the code along. And what I'll do is I'm going to save this code and have you take a look at it and change it the way you want. Most likely you're going to reduce the number of episodes and also refine it the way you want. But thank you for watching. See you and bye-bye.